So we're starting today section 5.1, and we're talking about angle measures, right? We're starting to get into the trigonometry of stuff in the college algebra trig section. I'm going to be honest with you. Chapter 5 is probably the most difficult information that we go over. So it's important that you guys put forth some effort. I have some of you that are still missing every test and quiz that we have taken. Guys, the longer you take to take it does not make it any easier. I can assure you of that. So try and stay on top of things as best you can. All right, the first thing we're going to talk about here is an angle. All right, just what an angle is made up of and what it looks like. You guys are all familiar with angles. I know you guys know what they look like. But there's different parts that are important that you understand when I reference the initial side versus the terminal side. Initial side is where the angle starts. Your initial side of all of your angles, guys, will always be the positive part. I'm going to write this down. Positive part of the x-axis. Meaning, right here. All right, this is the positive part of the x-axis. That's always going to be your initial side. That's where you're going to start from. And then terminal. What does it mean if something is terminal? Initial is where it begins. Terminal is where it ends, okay? So something that you need to be aware of is you guys are going to see positive and negative angles. If I have a positive angle measure, like 35 degrees, I would start here at 0, and I would go up this way. All right, I'm gonna use the terms up and down because sometimes we get confused with counterclockwise and clockwise. A positive angle starts at the x-axis, the positive side, and you go up. A negative angle, what do you think the negative angle does? Starts at the x-axis and goes which way? Down. That's it. All right, negative angles go down. So if it said negative 30, you would go down 30 degrees instead of up. So the negative in front of an angle just gives you direction. The angle is formed in the middle of these two rays, but remember the initial side is where the angle starts. It's always the positive part of the x-axis, and the terminal side is where it ends. Positive angles, you start at the x-axis and go up. Negative angles, you start at the x-axis and go down. Good, okay. Moving along. That's exactly what I just said. The rotation counterclockwise is positive angles. What I mean by that is we're going to start for a positive angle, start at the x-axis, and measure up. You're going to go up. Negative angles starts at the x-axis and goes which way? Down. Okay? That's all it's. When we talk about angles, you guys are super, super familiar with degrees. How many degrees are in a whole circle? 360, right? 360 makes a whole circle. So I have here, this is 0, up here is 90, this is 180, this is 270, right? We have 4 quadrants. This is quadrant 1, this is 2, this is 3, this is 4, right? We're all aware of that. So it's important that you guys can understand where the quadrants are located and what the angle measure is. Now, we're going to also talk about radians, okay? Radians, you guys, I don't know if you've seen much of a unit circle, but we'll talk more about a unit circle. But radians and degrees, it's just a different measurement, okay? Your calculator has 2 modes, radian and degrees. So when we go to do these things, you have to make sure that you're in the right mode, and we'll talk about that later. But there's 1 degree is 1/360th because there's 360 degrees in a whole circle. If I'm talking about radians, this would be 0 or 2 pi. 1 circle is 2 pi. So up here, 90 would be pi over 2. 180 is the same as pi. And then 270 is the same as 3 pi over 2. That's going to be important that you guys are aware of that. So you want to maybe make a mental note about that. All right, this is just describes to you what a radian is. I know a lot of you could care less to hear like how they got a radian and all that stuff, so we'll just move through it, no worries. When we talk about radian measures, this is how we get the 0, the 2 pi, the pi over 2, that sort of a thing. If you cut one whole circle into quarters, if I took a whole circle, which is 2 pi, and cut it into fourths, each one is a measure of pi over 2. So this is 1 pi over 2. If I had 2 pi over 2, what does that become? Just pi. here's 3 pi over 2, and here's 4 pi over 2, which becomes 2 pi. So that's where that comes from. I'll show you a unit circle. Now, we're going to convert. We're going to go from one to the other. Super easy. There's a conversion factor. But you don't even really have to memorize this. You just have to be able to think a little bit. If we're going to convert from degrees to radians, you're going to multiply by pi over 180. If you're going to convert from radians to degrees, you're going to multiply by 180 over pi. So the biggest thing to remember is 180 over pi or pi over 180. But you don't have to memorize like, oh, wait, what am I supposed to do? Because it's real simple to just look at. Let me show you what I mean by that. If we're going to express 60 degrees in radians, let's look at this first example. First of all, 60 degrees. 60 is over what number? 1, right? So if obviously, guys, I'm starting in what measurement? I'm starting in what? Is that a degree measurement or is that a radian? It's a degree because it has a little degree sign. So if I want to convert to radians, I'm going to want degrees to cancel out. Right? So where is the 180 going to go? Is it going to go on the top or is it going to go on the bottom? Why is 180 degrees going to go on the bottom? Because when you cross cancel, what happens to the degree sign? It cancels out. So you literally watch. I always write the degree sign so I see it. I see, oh, the degree on top and the degree on the bottom cancels out. And now we just use math. I can cross off a 0 on the top and a 0 on the bottom, right? Divide by 10. And then what number goes into both 6 and 18? 6 goes into 6 1 time. 6 goes into 18 3 times. So when I convert 60 degrees to radians, it becomes pi over 3. All right, the next example, B, what are we starting off in? Radians. What do we want to go to? Degrees. We're always going to go from one to the other. So if I have pi over 6, okay, what's my conversion? It's either 180 over pi or pi over 180. Where do you think the pi is going to go? On the bottom. Why would the pi go on the bottom? Because you want it to cancel out. Look, pi on top, pi on the bottom. 6 goes into 6 1 time. 6 goes into 180 how many times? 30. So pi over 6 is the same as 30 degrees. It's literally that easy. So like, look at this one. This is how you would do your web assign tonight. I'm starting off at negative 7 pi over 12. What does that negative tell me? It's a negative. What does that tell me though? What does that matter to me right now? It's going down. If they asked me to draw it, I'd start at the initial side and go down. But it doesn't matter to me in my conversion factor. I just know that my answer is going to be what kind of an answer? Negative. So in this case, guys, I'm going to convert. It doesn't tell me what to convert to, but I should already know because I'm starting off in what? Radians. How do you know it starts in radians? There's a pi. There's also no degree sign. So if I want the pi to cancel out, where do I put the pi? On the top or the bottom? So if I put pi here, then 180 goes on top. And this is where calculators are important, guys. Pi's cancel out. You can multiply negative 7 times 180 and then divide by 12 if you want to. Or you can cross cancel in the middle. What goes into both 12 and 180? 6? Agreed? Okay. 6 goes into 12 how many times? 2. And 6 goes into 180 how many times? 30. All right. Can I do a little more? What about 2 and 30? Okay, so this becomes 1 and this becomes a 15. So now the only thing I'm left with is negative 7 times 15, which is what? Negative 7 times 15. What is it? Yep. What kind of 105? It's negative 105 degrees. To convert from one to the other, it's either pi over 180 or 180 over pi. So now I look at this next one. Oh gosh, I got to convert. Well, remind yourself, 952 degrees is over 1. It's a whole number. I know this is bigger than one circle because how many degrees are in one circle? 360. Good. So if I want degrees to cancel out, where do degrees go? On the bottom. So I'm going to put 180 degrees on the bottom and a big pi on top. Question? Oh, sorry. All right, so first thing I'm going to do is I'm going to say, oh, good. My degrees on top cancels out with the degrees on the bottom. Now, again, you can just use your calculator, but you're not going to hit the pi sign. You want to leave it in terms of pi. So the first thing I'm going to do is just say, okay, well, 180 divided by 2 is 90, right? What's 952 divided by 2? 476. Can I divide that again by 2? Okay, I get 238. And then when I divide this by 2, I get 45. Is 238 divided by 5? No. Does 238 divide by 9? No. So this is just going to be 238 pi over 45. Leave it in terms of pi. Right, but 45 doesn't divide by 2. Right, you're just simplifying the fraction. And yeah, just leave it like that. Now, if they ask you in WebAssign to leave it in terms of radians and they say round your decimal to the nearest 2 decimal places or whatever, then that means they just use the pi sign. They said 238 times pi, like in your calculator, hit pi, and then divided by 45. That's if they say to keep it in decimal form. But 90% of the time, it's going to tell you to keep it in terms of pi. Questions? It says, a note on terminology. We often use a phrase such as a 30-degree angle to mean the angle whose measure is 30 degrees, all right? If you guys notice this, do you see how it says theta is 30 degrees or theta is pi over 6? You guys should be able to understand that this is in degree measurement. Why do you know this is in degree? Because of the little degree sign. Why do you know that this is in radians? Because there's a pi in it, right? When no unit is given, then it's assumed to be in radians. Say they told you that theta was 4. How do I know that's not degrees? What is it missing to tell me it's degrees? The little degree sign. So just make sure you guys are aware of that. Unless they tell you a little degree sign, you assume it's in radians. Now, when we talk about standard position, right? An angle is said to be in standard position if its vertex is at the origin, right? This is always what we talk about. You guys are very, very familiar with this. Angles being at the origin, all right? If I said an angle in standard position, what quadrant is A in? It's in the first quadrant. So that means that angle, angle A, has to be between what? It's between 0 and, what's up here? 90. Good. If I was going to tell you what it was between in radians, you guys would tell me 0 and what? What's 90 degrees in radians? What did we talk about at the beginning? Pi over 2. Good. If I look at this next angle, think about this for a second. What kind of an angle is this? How do you know it's negative? This is a negative angle. Because of the way that it goes. Good. What quadrant does it end up in? The second quadrant. But how many quadrants did it have to go through to get there? Yep, it's 3. So it's going to be a bigger measurement. I just want you guys to see this. What do you notice about this one? Positive or negative? It's positive. What else do you know? It's what? Would you say it goes all the way around? Good. So it's bigger than what? It's bigger than 360, or what's another way to say a whole circle? 360 degrees or 2 pi radians. Good. But you can visually see, guys, that that's bigger than 360 because it goes around one whole time. What about this one? What do you guys notice here? How many times did it go around? 2 whole times, then a little bit extra. Is it positive or negative? Yes, you can tell by the direction of the arrow. Positive. Good. All right. So you guys just need to be able to look at those things and be able to recognize different characteristics. All right. Co-terminal. If you're the co-captain or the co-pilot, you share responsibilities. You share duties, right? Two angles in standard position are coterminal if one of their sides coincides. What does that mean if something coincides? If it goes together, they share it. Okay? That's what coterminal means. What I need you guys to remember from coterminal is this. Plus or minus 360. If we're talking about degrees. And plus or minus what if we're talking about radians? 2 pi. One whole circle is 2 pi. If you guys can remember those two things, you'll be fine with coterminal. If you're asked to find angles that are coterminal, right? They share the same side. Meaning, if I have an angle like this, right? I have an angle here. You guys agree I have a positive angle right here in the blue? And then I also have a negative angle here. You guys see that? They share the same side, but their measurements are different. One of them is a positive number that's going to be less than 90. The other one's going to be a negative number that's going to be bigger than 270. But they're actually the same angle. They're just different directions. So when you're asked to find angles that are coterminal, if you want one positive and one negative, right, you're just going to add and subtract so you have a positive number and a negative number. So let's look at this first example, A. A wants... Let's do two angles that are coterminal with 30. Well, I'm starting off with 30 degrees, correct? So am I thinking 360 or am I thinking 2 pi? 360. So what you do is you take the angle measurement. Angle measurement always goes first. Let's add 360. So what's 30 plus 360? 390. So that's a coterminal angle. And then I'm going to subtract, and I get one negative one. So I'm going to say 30 minus 360, and I get what? Negative 330 degrees. Both of these angles are coterminal. They share the same side. You just keep adding till you get a positive number. You keep subtracting till you get a negative one. So if I have pi over 3 and I'm looking for coterminal, okay, here's my angle, pi over 3. When I see pi over 3, what do I think? I think plus or minus 2 pi. Good, plus or minus 2 pi. Whoops. Okay, this is a little more involved because we have to get a common denominator, but whatever. So remember, the angle goes first. Pi over 3 plus 2 pi. What's a common denominator between 3 and 1? No. 3. Would you guys agree with me? If I multiply the bottom here by 3, I have to multiply the top by 3, right? So 3 times 2 is 6. So a positive coterminal for this would be 1 pi plus 6 pi gives me 7 pi over 3. Good. Now to find a negative one, well, that means I got to subtract. So I have pi over 3 minus 2 pi. Again, what's a common denominator between 1 and 3? 3. So if I multiply the bottom by 3, then I multiply the top by 3. So I get 1 pi minus 6 pi gives me negative 5 pi over 3. When we find our coterminals, one answer should be negative and one should be positive. So in a case like C, okay, before I even do anything, this is what I always do. I write down that my angle given is negative 170 degrees. So immediately I think, okay, plus minus 360, because we're talking about degrees. So you take the angle, negative 170, and I'm going to add 360 to it. When I say negative 170 plus 360, I get a positive 190. Is that a positive number? Yeah, so I'm good. So you had like negative 400 and you added 360 and you still got a negative number, just add 360 again. But now I have my positive coterminal, now I need a negative one. So I'm going to say negative 170 minus 360. What's negative 170 minus 360? Negative 530. Make sure, guys, you have your signs. One has to be positive. One has to be what? Negative. Good. All right, let's look at D. Again, you can do however you want. I just think it's good to write down, okay, the angle that they gave me was 18 pi over 5. I'm talking about 18 pi over 5. So am I thinking about adding and subtracting 2 pi or adding and subtracting 360? Plus minus 2 pi, all right? So we got to do a tiny extra little bit of work here, but I have 18 pi, the angle always goes first, plus 2 pi. 2 pi is over 1. So what's the common denominator, guys, between 5 and 1? So if I multiply the bottom by 5, if I multiply the top by 5, 5 times 2 is 10, right? Yes? A common denominator between 5 and 1. So if I multiply the bottom by 5 and multiply the top. So when I add the top, what's 18 plus 10? I get 28 pi over 5. Is that a positive number? Good. I got a positive coterminal. So now to find the negative one, I'm going to say, okay, 18 pi over 5, and I'm going to minus 2 pi. Again, common denominator between 5 and 1. Common denominator between 5 and 1. 5. If I multiply the bottom by 5, I have to multiply the top by 5. So I get 18 pi minus 10 pi. Gives me what? 8 pi over 5. I'm looking for a negative coterminal angle. Is that negative? So what do you think I should do again? Let's subtract another circle, another 2 pi. So 2 pi over 1. Again, common denominator. What's the common denominator between 5 and 1? 5. If you multiply the bottom by 5, then you multiply the top by 5, and I get 8 minus 10 is what? Negative 2 pi over 5. Now is that a negative? Then you're good to go.
So for subtracting, you got to make sure negative.
Yep. You always want to, not even, just think of it, you always want one positive and one negative, because if they gave you a big negative number, you might have to add 2 pi or 360 like 3 times to get it to be positive. Yep. Yep. I just did it with this example because generally when you have to do pi, it's a little harder. You just keep adding or subtracting 360 or 2 pi till you get one positive, one negative. All right, let's move along. Oh gosh, now we got formulas, okay? When we talk about this on Wednesday, all Wednesday is gonna be is just formulas, but we're gonna give you the formulas. You just need to understand the parts of the formula. If we're talking about length of a circular arc, okay, think about this. That's the best circle you've ever seen in your whole life. All right, this right here is the circular arc. It's like the crust of the pizza, right? That's what that means. Here's your central angle. This is your theta. That's the angle in the middle. The length of the circular arc is the crust. So when I look at this formula, it says S equals R theta. That doesn't really mean anything to you guys. S is the arc length, right? That's the length of the arc. We're going to call it arc length. Theta is your central angle. It's the angle that they gave you. And then R is the radius. You guys know what R stands for, radius. One thing that is super duper important is that your theta, when they give it to you, you have to change it. Must be in radians. So if they give you a degree measurement, what do you have to do to that angle first? Do we know how to go from degrees to radians? Yes. All this is if you're solving for theta, they just manipulated the formula, but you guys know how to do that. You don't have to memorize a bunch of formulas. Just know this formula, and then you can switch it around however you need to. So let's just do it too. All right, this is where I just talked to you that the radian measure of theta, this right here needs to be in radians. When you plug it into the formula, it has to be in radians. So if you have a question like this, it says find the length. Let's do A. Find the length of an arc of a circle with a radius of 10 that subtends a central angle. That means it's across from. So they're telling me here that R equals how much? 10, right? And they're telling me that theta equals 30 degrees. I can't use 30 though. Why? It has to be in what? I just told you that. We just wrote it down. Theta has to be in radians. So before I do anything, I have to say, uh-oh, I got to change 30 over 1 into radians. Where does pi go? Where does 180 go? Pi goes on the top, 180 is on the bottom. Because I want my degrees to do what? Cancel out. So 0 and the degrees cancel, 0, 0. How many times does 3 go into 18? I'm left with 1 on top and 6 on the bottom. So my angle, my central angle that I'm going to use is pi over 6. You have to convert to radians first. So if you have the formula S equals theta times R. Okay, guys, what is theta? What is theta? Pi over 6, great. Theta is pi over 6. I'm going to times that by my radius, which is what? 10. Perfect. Keep your answer in terms of pi. I don't want decimals right now. Just keep it in terms of pi. So I'm left with, I can cross cancel, 6 and 10. What goes into both of those? 2. Good. So 6 becomes 3. 10 becomes what? 5. So my arc length here, the length of my arc happens to be 5 pi over 3. It is so super duper important. I cannot impress upon you enough. You have to convert that theta to radians first. All right, we're going to do example B and then we're done. I know I've been talking a long time. Happy Tuesday. All right, B. B's asking the same question, but in a different way. It's asking for something else. It says the central angle, theta, right, is in a circle with a radius of 4, subtended by an arc length of 6. Guys, subtended just means it's across from. So think about the stuff we need. S equals R times theta, all right? What did they tell me? What do I know? What are the numbers that they gave me? Okay, theta equals, do we know? No, what does it tell me 4 is? Okay, so theta we don't know. The radius is 4. What's my arc length? 6. So what is that letter? Is it the theta or is it the S? It's the S. Good. S equals 6. So we're not trying to find the arc length. They already told us that. What are we trying to find in this question? Theta. Good. So fill in. You guys can manipulate the formula so you have theta by itself. How would I get theta all by itself? Divide both sides by R. Good. Or you can just leave it like this and just solve it. S would be 6. I'd substitute in 6. My radius is 4. And then I have theta. So now what? How do I get theta all by itself? I'm going to divide by 4. Perfect. So theta equals, or when we can simplify that, right? If I asked you at this point to now change this into degrees, could you do that? Do we know the conversion to go from radians to degrees? Yes. It didn't ask you to, so don't worry about it. But when you are finding arc length and they give you theta that is in degrees, what do we have to do first? Have to. Got to change it to radians. If you guys don't do that, you just plug it in the formula, you're getting the whole question wrong. So please make sure that you're on top of that.